Good evening, everyone. So now we will discuss the last section C of the first internal data science paper. I am Ravi Jaiswal, MTech fifth sem student. So let's begin uh, from the first question. So it is saying discuss accuracy, completeness, consistency issues, missing timestamps, contradictory narratives, mistyped sections. Propose two or more quality dimensions relevant to legal analytics, timeliness, verifiability, and provenance. So the answer is accuracy. Accuracy means data may be incorrect or wrongly entered. Example, mistyped names, wrong timestamps. Second one is completeness. Completeness means some required information is missing. Examples include missing timestamps, missing sections in narrative, consistency, information conflicts with itself. Example, two different dates or contradictory statements for the same event. Two or more quality dimension. First is timeliness. Data must be up to date and recorded on time. Second one is verifiability, that which is also known as provenance. The source of the data should be traceable and trustworthy. Second question is for handling missing values in structured features. Discuss approaches, ignore tuples, manual completion, constant fill, mean, median, mode, imputation, classic, self, class specific imputation, most probable value, model based. So the first one is handle missing values using ignore tuples. Means remove records that have missing values. Second one is manual completion. Human examines the FIR complaint and the patterns and fills the missing value accordingly. Third one is constant fill. Replace missing values with a constant value, which is also known as fixed value. Like for example, zero or any value. It can be any value. The next one is mean, median, mode imputation. Replace missing values with average value, which is known as mean, middle value, which is known as median, and the most frequent value, which is known as mode. So we can replace the missing value with any of these values. Next one is class specific imputation. Fill missing values using statistics of its category. Example, same offense type. The last one is most probable value, model based. Use machine learning models to predict the missing value using other attributes. The third question is smoothing extracted scores. Use the evidence strength list from A2. So first one is smooth using bean means with bean depth 3. So steps, B1 is suggest ways to detect outliers, very high, rarely very high impact with low evidence. C1 is discuss other smoothing methods, bean, median, lowest, moving averages, lower, robust estimators. The answer of first one is that is A part. Smooth using B means bin depth of 3. It includes steps. First one is sort the scores, divide them into bin of sizes 3, compute mean of each bin means each group of size 3. We have to compute the mean of that. And for last one is replace each value in the bin with that mean. Means from that group, from we have to calculate the mean of each group and replace all the values of the particular group with that mean value. Examples include scores. We have this given. We have divided into bins and calculated the mean and replacing the mean with that, replacing all the values with that mean. B1 is ways to detect outliers. Values far away from the range too high or too low, which is known as outliers. Use Z score. If value is greater than 3 for standard deviation, then this value is known as outlier. Use IQR method, that is interquartile range. If values is beyond means it is less than quartile 1 minus 1.5 into IQR or quartile 3 plus 1.5 into IQR, then that value is known as outlier. The last one is using the graphs, which is also known as box plot or scatter plot. These graphs are very helpful for detecting outliers in the data. The C part is other smoothing methods, which like bean medians. Replace each bean with its median, most robust for detecting the outliers. Next one is moving averages, smooth using average of slide window. Next one is lowest low, which stands for loss is regression, local regression that fits small curves to smooth trends. The next one is robust estimators. Use trimmed means or weighted averages to reduce noise. Question 4. Discuss schema integration, handling redundant entries, duplicates across EFIR and physical logs, and resolving value conflicts. Example, differing monetary laws or section levels. The answer of that is using schema integration. Combines data from different sources like EFIR, electronic FIR, physical FIR, police logs into one unified structure. Then we will handle these redundant entries, remove duplicate complaints that appear in multiple sources. The next one is resolving value conflicts. Choose the most reliable source or use majority vote latest value or ask officer manual check when differences exist. Example, different monetary loss values. The last question is question 5. Explain normalization methods for feature scaling. A1 is min max, Z score using mean absolute deviation and decimal scaling. Min max normalization has a formula of x, which is a given value to us in the question, and from the data set we can find the minimum and maximum value. So it is becomes x dash equals to x minus mean divided by max minus mean. Z score normalization has a formula of x minus mu is a mean and divided by sigma, which is standard deviation. J discord using mean absolute deviation has a is the same formula of Z score normalization, but the standard deviation is replaced by mean absolute deviation, that is MAD. And the next one is decimal scaling. Decimal scaling shift decimal points until value becomes between -1 and +1. It has a formula of x divided by 10 to the power j. The next question is beginning case severity scores. This is a set of data we have given. We have to partition this data into equal frequency bins, equal width bins, clustering based bins, that is K means. Also, we have to explain implications for section mapping threshold. So the answer is we have 12 values. So far we have 3 bins, 4 values in each bin. If you use the if we use the first method, that is equal frequency bins, then each bin gets equal number of values. So we have a sorted list like that, and we will configure or bifurcate the list into 3 parts, each containing 4 data. So the bin 1 has arranged this, bin 2 and accordingly bin 3. B part equal width bins. Find range of the data, that is maximum minus minimum, which is equals to 220. If we have 3 bins, then the width becomes 70. So bin 1 will get the values in the range of 5 to 75, because it has a width of 75 minus 5, which is equals to 70. So we will get the value from 5 to 72, then we will get 92, then we will get 204 and 215 according to the equal width bins. Now we will see the third one, which is known as clustering based bins, which is K means. So in this we have a 3 clusters, low, medium and high, and we will place the values accordingly by using 4 values in each bin. Last one is implications for section mapping threshold. Bins help to decide low, medium, high severity categories. Thresholds change depending on binning method. Equal frequency, balanced groups, equal width, wide, low severity range. Clustering captures natural separation in real complaints. Question 7, feature selection for section mapping. Summarize with a flowchart the techniques for choosing attributes used by the DSS. A1 is forward selection, backward elimination, hybrid model. First one is forward selection, in which we have no references. Start with no references, add features one by one that improves accuracy. The most backward elimination starts with all features, remove the least useful features step by step. The last one is hybrid method, mix of both, add good features and removes weak ones. We have a flow chart of this also. We will start, then we can apply either of forward, backward and hybrid model. If we apply for forward, then we have a best risk features. If we apply backward, then we have a remove roast features. And if we apply hybrid, then we have to add a combo of best features and remove combo of roast features, then we will do stop. So that's all for this section. Friends, and also the internal work paper goes completed. If you have any queries regarding the concepts that I explained, please put down and comment. I will try to soon reach you out and explain all those queries. So thank you.